All right, so we've talked about how populations can change, but how do new species arise? Okay, so we're going to talk about a couple ways that we can see new species arising, and then we'll talk about this other thing called adaptive radiation. Okay, so defining a species is kind of tricky, but because this is Bio 100 and we're non-majors and we're going to use, for this class, we are going to use the biological species concept as our definition of what a species is. And this is where we're going to have a group of organisms that are going to be able to produce offspring that are fertile that can then go on to produce offspring. So the picture that I have here is an anti-example. So we have a horse, a donkey, and when we breed the horses and donkeys together, the result is a mule. Mules are not a species because mules are not fertile. So to make more mules, you can't just take two mules and mate them because they can't have babies. You have to go back and breed horses and donkeys together. Okay. Um, but if we can have two individuals produce a fertile offspring, then boom, they belong to the same species for the purposes of this species definition. Okay. And so speciation then is how we're going to get two species from a common ancestor. Okay. And the thing that is required is there has to be enough genetic difference that when these two organisms come back together, if they try to mate, they can't produce that fertile offspring. Okay. So let's look at our example that we have commonly around Flagstaff, and these actually are two very widespread species that are closely related to each other. So we have our common raven and our American crow. And if we go back through this phylogenetic tree, we can see that their common ancestor was fairly recent back in evolution. Okay, and so there must have been, right? So when this common ancestor was still alive, there had to have been a divergence in the evolutionary pressures for these different traits for these two species to arise from that common ancestor. So how does this work, right? It's because parents look like kids, kids look like their parents, and we should be able to see this, right? If, with every generation, parents look like their kids. And so how do we even get new species? Well, so one of my favorite authors had this thought experiment where he asked us to, in our minds, line up all of your ancestors for 120 generations. So have you holding hands with your mom and holding hands with her mom and 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 so on for 120 generations. And if you look at me and my daughters, we look the damn same. If you look at me and my mom, we look the damn same. And if you look at my mom and my grandma, they look the damn same. But there are these very slight differences between my grandma and me and my mom and my kids. Okay. So let's all say that we can agree that this is white. I know it's gray, but let's just pretend that it's white. Okay. And we can all agree that this is black, but where along this spectrum does it stop being white and start being black? And that's harder to define. Okay. So if we have all these moms and daughters lined up for generations, they're all going to be similar enough that we can say, yeah, those are all the same. But if we take the two ends and compare generation 0 and generation 120, yeah, we see that there's some significant differences between white and black. Okay. And that's the fossil record, right? It just gives us these snapshots in time. And this is the kind of information that we get from that fossil record is we don't have all the moms and all the daughters lined up. We get snapshots. And so we can say, okay, if there's sufficient genetic change, then we're going to call these two lineages different species. Okay. And we see this going on all the time. So what we might call a subspecies or a cultivar or a breed. Those are all terms for organisms that are different enough that we can recognize the differences in characteristics or differences in habitat, differences in physiology, but are close enough still to create those fertile offspring. So with our ravens, right, we have ravens all over the world, and depending on who you ask, they right, different authorities have different classification systems. So there's anywhere from 8 to 11 subspecies of ravens. Now, we're seeing that the Western raven and the South Eurasian raven have are experiencing different climates, different environments, and probably different evolutionary pressures, right? So they're undergoing different types of natural selection. At some point in evolutionary time, these things might diverge far enough that if they come back together, they won't be able to produce fertile offspring. And then at that point, that is when we're going to call them a new species.